This is a look at the 3 tables that are maintained on a device that is running a link state routing protocol, and in this case, specific to OSPF. So in the first output on the very top there, we did a show IP OSPF neighbor. So that is our neighbor table. The second output there is a show IP OSPF database, and in that we see our link state database, and that's followed by a show IP route OSPF, which is our IP routing table. So in our OSPF neighbor table, the first thing we see is a neighbor ID. Now the neighbor ID is chosen based on the highest IP address on an active interface the moment that you enable OSPF. Now that might not be the case if you have loopback addresses configured or loopback interfaces configured, because if you do, then OSPF is going to choose the highest loopback interface as its router ID. Now we can also specify the router ID, but in most cases, the router ID will dynamically be chosen for you based on the highest IP address on an active interface when I turn on OSPF, or the highest loopback address when I enable OSPF. We see the priority of this neighbor. We have a priority between neighbors because we are going to calculate on Ethernet segments a designated router and a backup designated router. Now in this case, in the state, we see that we are in a full state, which means we're fully converged, and we see that this neighbor is the BDR, or backup designated router. That would mean that we are the designated router. We won the election process. We also see the dead time here. When this expires, if we haven't heard any hellos from the neighbor, we'll remove the neighbor from our table. We see the actual physical address of that neighbor on the link, and we see the interface where that neighbor exists. In the show IP OSPF database output, we can see that this is an OSPF router with the ID of 10011, and it has the process ID of 1. Now that router with ID that we see there, 10001, is the same ID that we see right here. It's the ID of the router that's chosen by the highest IP address on an active interface when we enable the protocol. So if we were to go to that neighbor and do the same command, show IP OSPF neighbor, then he would see my neighbor ID of 10.0.1.1 because that's what was chosen as my router ID. We see the links and the router that advertised it. These are router link states. We also have network link states, and we're not going to go too deep into those. If you were taking the routing and switching exam, these would be important to you, but not so much from the security perspective, but just understanding that these are the links that are advertised. And these are sequenced, by the way. So we make sure that we maintain a current link state database by always checking the update, making sure that it has a higher sequence number, and if it does, then we accept the update. If not, we just drop it. Now in the show IP route OSPF output here, we can see that we have the code O. If we were to reference the code table in the show IP route command, it would tell us that that's OSPF. This is just a regular internal OSPF route, meaning it's in my area. And we also see the administrative distance of 110. Remember that was 90 when we looked at EIGRP, and we see here that the metric is 2. Now the metric that OSPF uses is cost, and cost is based on the bandwidth of the link. So essentially the higher the bandwidth, the lower the cost, but there's some little caveats around that, and we'll get to that a little bit later on.